So, okay, in this tutorial, firstly, we're gonna talk about, mainly we're gonna talk about main operations, okay? So insert and delete, we're going to consider 3 cases of insertion and deletion, the beginning, between 2 nodes, and at the end. So we will analyze these operations, firstly in single linked list and then in double linked list. In this video, we're gonna cover single linked list part. So firstly, we're going to analyze the basic concept. I'm going to show the graph and then we will analyze basic concept and then we will implement each function step by step in C++ in program. So let's start with single linked list. So, okay, this is insertion at the beginning. As you can see here, this is the linked list and we're going to insert a new value. This is 10 to the beginning, okay? So as you know, head is a temporary variable that's called a reference pointer, yeah? Reference pointer that points to the beginning, to the very first element, okay? So if you want to insert a new value, firstly, we have to connect new value to the current node, to the current head. For example, here it's 20, so that's why as a step 1, we connect new node to current, yeah, this arrow. And then, as you can see, don't look at this head. As you can see now, the very first element is 10. So that's why it's not acceptable that head will point to the 20, okay? It should point to the 10 because now the very first element is 10. So that's why in step 2, we update head to new node. So firstly, connect next to current, initial head, and then update head. The cost of operation is 0.1 because it's regardless of the size of input. So, if the linked list is size is 20, 100 to 1000, it always takes 2 steps in order to insert the new node at the beginning. Okay, so let's implement it in C++ in a program. As you can see here, I've created this main CPP. Here you can see node class, it's pretty understandable. So here our insert start function. So what is it? It's a new value, it's a value of the node. In this case, it's 10. So what is it? It's head, it's a pointer, it's head. And you can see here, I'm gonna using 2 asterisk symbols, and this is because we are receiving this pointer as reference. We're not receiving the pointer's value, we're receiving as its reference because we're going to change entire linked list. If you kind of write only 1 asterisk, it will be kind of a pass by value, and the value of the head will not be changed in the main CPP. It will be changed only in this block, but it's not acceptable for us. Okay, so let's write. So anyway, I explained to you the very basic scenario, but also there are special cases. For example, what if the linked list is empty? So we shouldn't forget about this kind of occasions also. So by the way, I have to always tell you that we're not going to use head. Head is real precious. We have to save it. So that's why we will use always temporary variable called current. But in this case, in certain side, it's okay. I will show in next operation, we're not going to use head directly, we're going to use current. We will assign head to the current and use it as a reference. So here it's okay. So we're creating new node. In this case, let's say it's 10, yeah? We're creating new node. See? So, and then the very special case, what if current, what if head, yeah, is null PTR? What if head is pointing to null? Head will point to null. That means there is no element in linked list. It's empty. Then we'll just assign to head new node. Yeah, that means head should point to new node. Yeah, that's it. And heads next is going to be null because we can in constructor we're kind of passing a default null parameter. So that's why there's no reason to write here head next is null PTR. It's already there. So we're just assigning to the head new node. So then we consider the basic case, the basic scenario. Else, if it's not null PTR, as you know, we are setting new node next to current head. Yeah, initial head. Yeah, this one we are doing step 1, and then we are updating head to new node. New node head should point to new node. Okay, so that's it. We are done. So now we are going to consider the next operation. Firstly, just please let me make sure that, yeah, everything is good. So I'm recording. Okay, so next operation, inserting between two nodes. Here, the thing is a bit trickier. Firstly, we have to read the position, and we're going to receive the position of the node where we're going to insert the value. Okay, so that's why we have to use the loop in order to reach this position. Let's say in this example, we're going to insert the value in position 3. Okay, so 1, 2, 3, indexing start at 1. Okay, for easiness. Okay, so 1, 2, 3, we're going to insert something in position 3. So firstly, we're going to reach this third position. Initially, in the third position, there is a node. Which one? 40. Okay, this is a current, and we have to always track the previous node. Okay, so third position, current is 40, previous is 20. So the step 1, we have to connect new node next to current. So 30, you have to connect to the 40. The most cases, what students do or what friends do, they connect previous node to the new node and new node to current. That's also okay, that's also okay. If you if you have two pointers, I mean, okay, let me explain it. If you have a current previous node and current node, that's okay. You can connect firstly in previous node to new node and new node to the current, new node next to the current. But if you're not using previous node, if you're using only current node, you have to be real careful. First, you have to connect new node to the current. So that's why for easiness, for kind of not making mistakes in the future, let's connect firstly new node next to current node. So then we update this arrow because previous nodes next won't be 40 because new node points to the 40. So that's why in order to link this part of the linked list, with this part, we have to connect previous node next to the new node. Okay, so cost of operation is 01 because we are using a loop. So let's implement the in C++. Of course, we have to also consider some special cases. We're going to consider them in the code. Okay, firstly, I'm going to create current because we're not going to use head rule previous. We have to save head. Let's use temporary variable current. That means current node. And then we'll have to use also previous. Previous, it's going to be null PTR right now. And new node, comma, new node. I have to insert new. New node passing value. We have passing value, and in this node class, we're kind of creating instantiating variables. Data will be value, and next will be null PTR by default. Okay, so right now let's consider a very special case, but first we have to also write indexes. We have to keep track of indexes. As I've said above, we're going to start indexing at 1. We will implement these steps only if the index equals to position. For example, if it's 1, it's going to be incremented in the loop, but index is 2, it's not a key. Index is 3, that's okay because it's kind of equal to the position. So we have to keep track of index, and we're going to also find the length of linked list. Okay, as for the loop, we need the length. Okay, so that's why I'm writing max. Max means the length of linked list, length head. I mean, I have implemented beforehand length function that returns the size of the linked list, as you can see here. Counter 1, it will go until the current is null PTR. Current is null PTR when it reaches the next PTR of the last element. So it will increment current and then return current. Okay, that's a simple function. Okay, max is the length of linked list. So right now I'm going to consider also the factor that user can input wrong position. For example, if position is bigger than max, is bigger than length of linked list, or if position is less than 0 or less or equal to 0 because we're starting indexing at 1, so then we have to take some measures. Kind of exception, but we're using just loop. This loop will be executed until the user enters correct position. Okay, position, for example, if max is excuse me, if position is bigger than max, or if position is less or equal to 0, we're going to say position is out of range. Try again. Okay, try again, and then we're gonna send position. We're going to receive position, and once a user enters correct position, this will terminate. But if position is okay initially, this block will not be executed. So now we're going to come to special cases. For example, if current is null PTR, okay, if current is null PTR, that means linked list is empty, so that's why we're going to insert at the beginning. And also, see, if position is 1, what does it mean? If position is 1, user wants to insert the new node to the beginning, okay? So that's why this condition is same. This condition, when current is null PTR, there's no element, and user wants to insert at the very first element, that means we're going to insert at the beginning, okay? For example, if linked list is empty, we will insert at the beginning, and if user enters the position 1, we're going to insert at the beginning. So we're going to use this concept. There's no reason to write this code again there. That's why we just will call our function that we have written, insert at start here. So we're going to pass the head and we're going to pass the value. And this function will do job for us. If insert, if position is 1, or if current is null PTR, this block will execute it and it will return here. So then we're going to write return so that the rest of the code will not be executed. Okay, it will not be checked. We will return here. We will stop function call. Okay, function execution will stop there. So, and then we're going to consider also if position is max. What does it mean? What does it mean if position is max? I told you that max is the length of linked list. If position is max, that means we're going to insert at the last. Yeah, we haven't implemented code for it yet, insertion at the end here, but we'll implement it right after this function. So that's why let's write here kind of insert at end. Yeah, we will implement it a bit later. Just write here insert at end and value, okay, and we will return. So we will write for it, I mean, implementation here. So, but idea is clear, yeah? For example, if position is max, we're not going to write code here. We're going to just call insert at end function because max is the length of the linked list. And if we write if position is max, let's say, that means user wants to insert the element at the last node. So, and then we have come to our basic normal scenario when the user enters a position, for example, between, for example, 3, okay? So let's say we're going to write while true. I'm going to explain why I'm going to write in this loop a bit later. So if position, okay, if position is equals to index, some code, okay, and then previous, we're going to track previous node, previous equals to current, current equals to current next. So then index plus sorry. Okay, so here, what does it mean? If position equals to index, we're going to do some code and we're going to return, we're going to return. We will stop the execution. So that means until the position equals to index, we're going to save this current node. It will start from here in previous PTR, and then we're going to increment or update current to the next. For example, initially 10, let's say our position is 3 and index starts with 1. Firstly, it will check if position 3 is equal to 1. It's not equal, so it will come here. So current is 10, We're going to save 10 node in previous, and we're going to set current to current next. It's going to be 20. So now previous is 10, current is 20. So index is 2. It comes here. Is 2 equals to 2? Is 3 equals to 2? It's not. So current is 20, okay? So as you know, current is 20. So we're going to save 20 in previous PTR, and we're going to update current to the current next. Current next is going to be 40. So now current is 40, previous is 20, okay? So index is 2, and then it becomes 3 here. So then it will come again here, position equals index, yeah, 3 equals 3. So then we're going to write the code. Okay, so now our previous PTR is 20, as I explained right now here, and then current node is 40. So let's write then implementation, this implementation. So step 1, what's step 1? Step 1 is new node next is equals to current. This one, yeah, we're kind of linking new node next, so it is next PTR to the current 40. And then we're going to update this link, as I've said, explain it to this one, okay? We're kind of running out of time, so let's be quicker. Previous next equals to new node, okay? So it's pretty understandable, pretty clear. So if you have any kind of questions, unfortunately, yesterday I kind of forgot to click the button called record, so that's why I'm recording again. So if you have any kind of questions, just write in the comments, write in the chat, yeah. So I will try to answer them. I will definitely answer them. And also you can find the source code for it in our GitHub repository. It will also be shared, okay? So now I'm going to implement insert at end function, and then we're going to unfortunately stop our tutorial for now. And I will create new tutorials, firstly for deletion, yeah, single linked list deletion operation, and I will create the video for insertion and deletion of operations of double linked list, okay? So now we're going to implement insert at end, and then we're going to stop our tutorial, and in the next tutorial, I will explain you deletion operations of single linked list, and hopefully if I have time, I'll also share with you insertion and deletion operations of double linked list. By the way, you can also find in our repository the lead code question related to linked list. It's about removing the ends node, kind of deleting ends node from the end. So check in the description. I've also kind of shared this link, and also I've kind of added in our repository the solution, my solution in C++. So it's a medium level problem. So please study it. Please try to solve this on your own, and then check my solution, run it, compare it. If you have questions, please contact us. Okay, we're always here. We're always ready to help you. So right now, let's focus on insert at end function. Okay, yeah, you can see. So here is a concept. We're going to insert at end, okay, at the last element. That means we're going to connect the next PTR of the last node to the new node. See, the last node of the linked list is always points to the null, okay? This is a logic. If the current, or if the, excuse me, not current, current node or last node, let's say, points to the null, that means this node is the last, okay? So that's why we're going to first reach the node with a loop, okay? And then we're going to firstly update this null, this current node next picture initially points to null because it's the last element, but now we're going to update it to the new node, okay? So now current node, or let's say initial last node, should point to the new node, and then new node is going to be the last, yeah? Why? Because it's the last element. So how do we define it to be the last? We have to set new nodes next to null, so that when we reach this node, and when we reach the next node, it's a null, so that we can say that, hey, 50 is a new node, is the last node, okay? So initially, current node is the last node, it points to the null, but then we update this current node to the new node, and then we set this new node next PTR to the null, so that to define this to be the last element, okay? So cost of the operation is O and, because we have to read the last node. For example, when you want to insert at end and the size is 100, you have to loop and you have to read the element in the index 100 in order to, or not index, let's say hundredths node, in order to insert at the end, okay? So it's ON operation. So let's implement it here. Of course, we have to consider some special cases. For example, if linked list if head is null, so that means linked list is empty, so that we have to call our insert at beginning function. Yeah, we have to insert at the beginning, so we don't have to write code again here. I mean, implementation for insert at beginning, we have to just call this function. So let's come here and implement it. So we're going to use, of course, current, not going to use head. Head is precious. I have to save head, have to use reference current, okay? So hopefully it's visible. So let's continue. Let's write new node, new node value, okay? If current is no PTR, that means if it's empty, linked list empty, let's call just insert, not end, insert at start function, pass head, pass value. Okay, so then we're going to write a return, because after when current is no PTR, we're going to call insert at end function, and then after implementation, after the execution, it will come here and it will go to the execution of the rest of the code if you're not going to write return. Yeah, if you write return, it will finish. So this is the logic that we want. Yeah, there's no reason to continue execution of this node, this code, once we have inserted the value at the beginning. So we're going to write return. It will finish the execution of the function. So if current is not no PTR, if there is a linked list, so what we're going to write? We're going to write while true, okay, while true, let's say, if current next equals to null PTR. What does this mean? Some code, okay, some code. So until it just pass current, update current to current next. So I mean, we are moving, we're kind of moving. So we're checking this condition if current next is null PTR. Excuse me, yes, yeah. If current next is null PTR, that means if current next node is null PTR, it will only be met. This condition is going to be met only when we reach the current, I mean, the last node, when its next pointer is null. So that means we're going to check this. For example, current initially is 10. We're going to check is 10's next is null PTR here? No, it's 20. So we update it. Current is equal now current next. That means current is now equals to current next. It is 20. So then we compare it. 20's next PTR is null pointer. Not, it's 30. So we're going to reach, and then we come to 40, and then we compare here. Is current next 40's next PTR is null? Yeah, initially it's null. So we're going to implement these two steps. Okay, so okay, here I'm going to write the code. New node next is null PTR. First let's connect. Firstly, it's a second step. First we connect current node next to new node. Okay, so current next equals to new node. So that means once we reach here, this current node is not pointing now to null, it points to new node, and then new node next points to the null. So that's it, we're done. So hopefully you liked this tutorial. So soon you're going to, excuse me, we're going to write here return after the implementation here. If you're not going to write here, this level execute forever. It will be error, runtime error. So don't forget to write return, because once these steps are executed, we're going to finish the execution. We're going to finish the call of the function. So that's it. I'm going to make another video for deletion functions. As you can see, delete at the beginning, delete between two nodes, delete at end. And also I have insertion and deletion for double linked list, as you can see here. So you can see here, so this, and finally I have really powerful, useful links, so you can read them. It's a Medium, it's long articles, and University of California, San Diego's videos. They're really powerful. I'm just really recommending you to check these useful links. But anyway, you'll be shared with this slide with all the supplementary materials and videos soon. So see you soon in next tutorials. Thank you. Yeah.